Hello friend, in this video we are going to look at how to solve the Parachutist differential equation. Yeah, it's a little bit going to be difficult with a lot of gymnastics, but it is very important to master the principles here. So this differential equation, as we have already explained in some of my videos, dv dt plus k out of mv squared minus g is the Parachutist equation, which is first order differential equation. Now, we can solve this with very many ways, but in this particular video we are going to use separation of variables. So if I look at my equation, this velocity is changing with respect to time. This is a constant, this is a constant, this is a velocity squared minus g, and this is a constant is equal to 0. Therefore, if I take these values or this the other side, I will remain with mg. It is actually going to be g minus kv squared out of m. But now I want to keep v squared here. I want to create a v squared and also create a constant here so that it makes my life easier. So what I do, I factorize k out of m outside the brackets. So that dv dt is equal to mg out of k minus v squared cross brackets k out of m. Now when I look at this, it means I can bring the different variables together. I know this is dv, so I will correct whatever is having velocity this way, and the other things which have time, I will take them the other side. So it means my equation will be dv out of mg out of k minus v squared is equal to k out of m dt. So once you look at such an equation, it means I can immediately introduce integrals and solve it. But let us be patient a little bit and approximate mg out of k to be a square of a particular constant, let's say c. So let mg out of k equal to c squared. It means c will equal to root of mg out of k. So when I substitute it in here, it gives me dv out of c squared minus v squared is equal to k out of m dt. So this one will immediately show me that at the end of the day, if I introduce the integral signs, it will create something. I play around with it. If I multiply a negative 1 here, negative 1 here, negative 1 here, and a negative 1 this way, it means I can, if I put it here, for example, here it's not there. If I put it here, it means I can get back to c squared minus v squared. So what I do, I'll just take it immediately to the other side, and it becomes integral of dv v squared minus c squared is equal to integral of negative k out of m dt. So now I look at this and it tells me this is actually a difference of two squares. If I have a squared minus b squared is equal to a plus b into a minus b. So that means if I use the difference of two squares, I can say this is integral of 1 out of v plus c into v minus c dv is equal to negative integral of k out of m dt. Now, if I use partial fractions, please, if we use partial fractions, you can try it out. Partial fractions will give you 1 out of v plus c into v minus c will equal to 1 out of 2c into 1 over v minus c minus 1 over v plus c. So at the end of the day, I will just substitute this 1 out of v plus c into v minus c with 1 out of 2c into 1 out of v minus c minus 1 out of v plus c. So when I bring it in here, if I integrate, this is 1 out of 2c. If I integrate this, it will bring, it means integral of 1 out of v minus c dv is equal to ln of v minus c. Likewise, integral of 1 out of v plus c with respect to v will give you natural logarithm of v plus c. So now we bring it in here and substitute it in. This will be 1 out of 2c into natural logarithm of v minus c minus natural logarithm of v plus c is equal to negative kt out of m plus a constant of integration, say c1. So if we use the laws of logarithms, it means I can have logarithm of the same base. If I'm subtracting, then it means I can divide the powers, meaning that natural logarithm of v minus c divided by v plus c is equal to negative 2, because this will cross multiply this way. It becomes negative 2c kt out of m plus 2c c1. Now, if I want to remove the natural logarithm, then I will introduce Euler's number, because if I have, let's say, natural logarithm of x equal to maybe k, it means x is equal to exponential of k. So using the same example here, it means v minus c out of v plus c is equal to exponential of whatever is on the other side. But if it is on the other side, it will be negative. It will be, first of all, exponential of negative 2ck out of mt plus 2cc1, but using laws of logarithms, indices, and powers. If I have this base to power this, it means I can introduce this base again, minus 2ck out of m, then times the same base to power this power that I have 2cc1. So it is what I have done here, and therefore it means if I cross multiply, it means v minus c is equal to v plus c exponential of negative 2c kt m. If I call this 2cc1 to be a constant, for example a, then it means I can say, because these are constants and therefore the whole of this will be a constant, v minus c equal to v plus c exponential of negative 2c kt divided by m, I'll multiply by a constant a1. Therefore, if I open the brackets here, it means v minus c is equal to v. If I multiply here, it means I will multiply v times this times a. So it will be va1e, or exponential of negative 2c kt out of m plus, I take this plus s a1c exponential of negative 2c kt divided by m. And therefore, if I correctly write terms together, I'll end with v into 1 minus a1 exponential of negative 2c kt out of m, cross brackets, is equal to c into 1 plus a1e exponential of negative 2c kt out of m. Therefore, the velocity of the parachutist will therefore equal to c into 1 plus a1 exponential of negative 2c kt out of m divided by 1 minus a1 exponential of negative 2c kt out of m. So it means, given the boundary conditions, all the constants can be obtained. These other constants, for example, M, K, and C, are known. Of course, they must be known. Because if it is mass is known. That K, basing on what it is equal to, that K, we said it is this coefficient of drag times density times area divided by 2, we can get it. Also this C, we have defined it above, it can be also defined. And the expression therefore for velocity of a parachutist can be ascertained. Thank you so much for following.